Hello, welcome to Mr. Miles Maths. Today's lesson is going to be on Pythagoras Theorem, one of my favourite mathematicians. And if you're wondering who this little fella is, been through the first few videos, then he is supposed to be Pythagoras, although whether it's an accurate depiction of what he actually looked like, I don't know, but that's who he's supposed to be. Pythagoras Theorem, we're going to go through a little bit of theory first, and then we'll get straight into some questions after that, as that's the best way of learning. So let's have a little look. So Pythagoras' theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides, which sounds like quite a mouthful. It sounds like there's lots going on here. There's a few definitions we need to make sure we're happy with before we can start looking at how these questions work. So one of the first things is we need to understand what the hypotenuse is. And we need to know how to square things. We've got the word squares in here, so we need to make sure we're okay with that as well. We'll go through that too. So the first thing we're going to look at is the hypotenuse. The hypotenuse is the longest side of a right angle triangle. So first of all, I'm going to draw myself a right angle triangle, hopefully with the help of this program. So to indicate it's a right angle, I put a little square in the bottom corner like this, down here. So that means that it's 90 degrees. Pythagoras' theorem only works in right angle triangles, so it's really important that that right angle's there. As soon as we see right angle triangles, we can use Pythagoras' theorem. The hypotenuse, this fancy word, just means the longest side, and the longest side is always opposite the right angle. The bigger the angle, the bigger the side opposite that angle in triangles. So 90 degrees must be the biggest angle in this triangle, and therefore the hypotenuse has to be the side that I've labelled with a capital X there. So the square on the hypotenuse, which is this side, is equal to the sum of the squares of the other two sides, which are here and here. So rather than having to write that out every time we're going to use Pythagoras' theorem, we're going to get this into an equation. And there's various ways people remember this, but I always remember this as Pythagoras' theorem as by Pythagoras, a squared equals b squared plus c squared. Again, we're going to relate the a to the hypotenuse. So it's really important that that is the letter by itself on that left-hand side. That's one of the most important things about this theorem. The hypotenuse is by itself on one side. Some people learn c squared equals a squared plus b squared. That's fine, so long as the c translates as the hypotenuse in green there, or the green matches up. But we're going to learn it, or I'm going to teach it, where the hypotenuse is a. I'll write it in red so it all matches up. So a squared equals b squared plus c squared. So the square on the hypotenuse, a squared, is equal to the sum of the squares on the other two sides. So we're going to call the other sides b and c. And the first thing I recommend when you do these questions is always to label your triangle. The labeling of the triangle should always be the same. We always have a opposite the right angle on the hypotenuse, and then b and c, doesn't matter which way around they go, because b squared plus c squared is the same, whichever way around you write it. But the a must be by itself if you can have it as a squared equals b squared plus c squared. And every time I use the formula, I'm going to write it down, because then I'm much more likely to remember it. That's the theorem. Best way is to get stuck into questions on this. So, number one. First thing we're going to do is label the triangle. Opposite the right angle, we label A. B and C, it doesn't matter, they are left over. And once I've got it all labelled like this, I can then write down my formula. It's a right angle triangle, we can see the right angle here. So we can use Pythagoras' theorem, and I'm going to write down my formula, which is a squared equals b squared plus c squared. And then all I have to do, because I've labelled the triangle, is substitute. So replace all those letters, A, B, and C, with the values that they represent on my triangle, on my diagram, which should be nice and easy because I have labelled each of them. So A is here, A is the X, so I can put X in place of A. Whenever I substitute, I should always put brackets around the thing that I'm substituting, otherwise mistakes creep in. B is 4 centimetres. We can see that there, so we can replace B with 4, also in brackets. And C is 3 centimetres, so I can replace C with 3, also in brackets. And then once I've got it into the equation, like lots of maths, I can almost kind of forget Pythagoras' theorem now, and I just need to solve equations. There's loads of videos that I've done on solving equations, so make sure you watch them because they will certainly help. But we need to manipulate this Solve means get the x by itself. So x outside with a square outside, sorry, is just x times x is just x squared. So the brackets don't make any difference this time. 4 squared is 16, 4 times 4, and 3 squared is 3 times 3, which is 9. So I can just kind of start simplifying this to make things easier for me. Notice how my equal signs line up. I'm solving an equation here. X squared doesn't change. I can add 16 and 9 to make that a bit easier. X squared equals 25. To get rid of squaring in maths, I do the opposite. So now I can square root both sides. So take the square root of x squared, the x drops out. Take the square root of 25. And we can use our calculators, or hopefully we realise that 25 is a square number, and we get x equals 5, and we should always put our units on. We're working in centimetres. So x equals 5. This is a 3, 4, 5 triangle. We actually call it a Pythagorean triplet when the whole number's like this. Let's have a look at 2. So same principle. The first thing to check is it a right angle triangle? We're finding lengths as well. Pythagoras always finds lengths, nothing else. Opposite the right angle is the hypotenuse. We want to make sure that's our A. B and C, doesn't matter which way around they are. And then we're ready to start the question and get everything into our equation. So we should always write down the formula. A squared equals B squared plus C squared. And then we can substitute in our values. So wherever the A is, which is opposite the right angle, in this case is our X, that goes in brackets, always in brackets. B, we've labelled as the 8.7 side. So I can put 8.7 in place of B, 8.7 squared for B squared. And then C is 6.2. So we can put 6.2 in brackets for C, and then C squared is 6.2 squared. X squared won't change. We can't square x. We don't know what x is. 8.7, we can get our calculators out and put 8.7 squared in, which gives us 75.69. 6.2 squared, we can put in our calculator as well, 38.44. And then we can add those two things together. So 75.69 plus 38.44 to give us 114.13. So notice the numbers are a little bit more difficult here, but we can just use our calculator. It's the principle of Pythagoras that stays the same. We still label a triangle the same way. It still works out in the same way. And then to get rid of our square, we square root both sides, keeping it nice and neat. And again, to our calculators for that, square root of that. And then we get x equals 10.683, and the number carries on. So I'm going to put a few little dots to indicate that it carries on. And then we're going to round this. We tend to round lengths to 3SF, 3 significant figures. So here the 8 rounds the 6 up to a 7. So we'll get 10.7 centimetres, and we should always write our units, the centimetres, and the degree of accuracy to which we rounded, which in this case was 3SF. Question 3. 2 more questions to look at. And you'll notice with question 3, it's slightly different, okay, when we come into it. But we always label the question the same way. It's still a right angle triangle. Here's our right angle. It's still finding lengths. We're asked for x, which is a length in this case. So we look to the side opposite the right angle. That's the hypotenuse. We call that A. Always the same. We call the other two sides B and C. It doesn't matter which way around they go, but A must be opposite the hypotenuse if we're going to use A squared equals B squared plus C squared. Write down your formula, that way you will remember it, and it's nice and easy to see the substitution happening as well. So from here, A is 13.5, and that's where this question is a little bit different. People always want to put the x first, but it's not the x that goes first, it's the A that goes first. Wherever the A is, and whatever the A is represented by, that's going to go here. So A squared is 13.5 squared. This time B is the x. So we put our x in place of B in brackets, squared. And then C is 9.4. So we put 9.4 in place of C in brackets and have our squared there. So it's more about the setup of Pythagoras and the principles. Don't think, where's the x? Am I using the x? You always label the same way. A opposite the right angle, B and C the other two sides, doesn't matter which way around. Write down your formula, sub in, and then we just see where the equation's at. And hopefully, if your equation solving skills are good, or you've watched my videos, if you haven't, then please do, they should help. You can solve this equation nice and easy. So 13.5 squared, we can simplify this on our calculators to 182.25. Equal sign still lining up nicely. Be nice and neat, it makes things easier. X squared, we can just write as x squared. And then 9.4 squared again, you can use your calculators to help you, is 88.36. So the only difference in the question is how I solve the equation, and that's just because the numbers and letters have gone into the equation slightly differently in this case, because of the way the question is set up. So to get the x squared by itself here, I need to get rid of the 88.36. So if I want to get the x by itself, first of all, I need to get the x squared by itself. And to get rid of the 88.36, I'm going to subtract 88.36 from both sides to balance it out. Okay, in the earlier videos, I would tend to write that at the sides, but I think by now, hopefully, we're quite happy knowing what happens if we see that step in solving equations. So subtract 88.36 on both sides. That leaves me with just the x squared on the right, which is great. I can do 182.25 minus 88.36 on the left, which gives me 93.89. And I can square root both sides to give me x. I will keep the x on the right for now. So square root the right, you get just x, cancels the squaring, and then square root the left. And again, we can put that into our calculators. Square root of this is 9.689. I'm now going to write the x first. So x equals 9.689. Again, the number would carry on, and I'm going to round to 3SF. So the 8 is the third significant figure, that rounds the 9 up. The 8 is the third significant figure, the 9 rounds the 8 up, so it becomes 9.69. We're still working in centimetres, so we add that in, and we should always add our 3SF, our degree of accuracy, in as well. So slightly different setup on this question, but the principle of Pythagoras remains the same. One more question like this. So again, right angle triangle, we can see the right angle here. Finding lengths, x is a length. So Pythagoras theorem is a very favourable choice. And then we label up as always. So always opposite the right angle, we're going to label A. Other two sides don't matter, B and C. And then we can write our formula down, A squared equals B squared plus C squared. And then we can substitute in. Notice how it's always the same start, always the same method for substituting. It's just how we solve the equations and the different numbers that change the question. So A was opposite the right angle, which is 12.7. So that goes in place of A here, 12.7 squared. B is x. So that's going to go in here. So we'll have x squared in a bracket. And then C is 9.6. So that's going to go in here. So we'll have 9.6 squared. Always put your substitutions in brackets. And then calculator to help you out. 12.7 squared is 161.29. X squared is just x squared, can't do much with that. 9.6 squared is 92.16. And then we need to solve this equation. So how do we get the x by itself, or the x squared, first of all, by itself? I need to get rid of the 92.16. And to do that, I will subtract 92.16 from both sides. When I subtract 92.16 from the right, I'll just be left with the x squared. Great, a bit close to the x. And I can do 161.29 minus that 92.16 to give me 69.13 on the left. And then to get rid of the square, I square root the right, which means I have to square root the left. Whatever I do to one side, I do the same to the other. So I can take the square root of that with my calculator again, which is 8.314. And the number continues. Don't want to write them all down. And then I'm going to round this to 3SF again. So again, 3SF, the third significant figure here is the 1. The 4 rounds that down. So this stays as 8.31 units, centimetres, degree of accuracy, 3SF. And that's Pythagoras theorem. I will do another lesson on this. Pythagoras theorem doesn't change, but I'm just going to make the question slightly more difficult, throwing things like 2x or 3x or brackets, or kind of a multi-stage question. But the principle of Pythagoras should stay exactly the same, and that's the most important thing here. and that's why it's worth going through the theory. Always worth writing down the formula at the start of every question, like I do here, because then you'll remember it, and then it's really easy to see that substitution if you've labelled your triangle correctly. I hope this helps with Pythagoras Theorem. Hope you like the video. Please hit the like button if you have done, and hit the subscribe button if you want to watch some more videos. Any requests, please ask for lessons or particular questions. Thank you. See ya.